All right, so yesterday, ladies and gentlemen, we talked about composite functions, and today we're doing chapter 5.2, which is one-to-one and inverse functions, okay? We're going to talk about one-to-one functions, but the big thing for today is understanding what an inverse is. The reason why we're talking about inverse functions is because this chapter is called exponential and logarithmic functions, and they are inverses of each other. So you got to understand what that means, and then hopefully get a grasp on why things change the way they change from exponential log and back and forth. So we have three goals today. Number one, determine the inverse of a function. For us to understand that, we have to understand what a one-to-one function is. We're going to obtain the graph of an inverse function from the graph of a given function. And then we're going to find the inverse. This is the big one. We're going to find the inverse of a function. That is denoted with a little f with a little -1 on top. Okay. All right, so let's get started here. Let's get started. First off, we have one-to-one function. For us to understand a one-to-one function, we got to go back to what a function is. Remember, for a function, every x has, in the domain, there's exactly one y. Or every person has exactly one birthday. All right, and we had, I can't remember who it was, you dirty dog out there, who had 2 birthdays in here? Was it Gavin? Who had 2 birthdays?
Yeah, it was
me. You dirty dog, you can't have 2 birthdays, right? Well, now, for it to be a one-to-one function, all right, no y in the range has an image more than 1x. Okay, so a function, every x can only have one y, every person can have one birthday. Well, for a one-to-one, every y can only have one x. Or every birthday has only one person. So think backwards. Okay, now think about how many people would be on planet Earth. All right, planet Earth, how many days are there in a year? And that's how many people would be on this planet. How many people would you guys have? And this is a trick question. Think about it. How many people would be on this planet if every person only had one birthday and every birthday has only one person? What do you think? How many people would be on this planet? It's a trick question. Take a guess. How many birthdays can there be?
365.
Close. You're off, just one by one.
366.
Yes, 366, because everybody forgets about a leap year, right? February 29th, that would be a birthday, okay? So that was a little trick question. Nice job, okay? Just having a little fun. So there would be only 366 people on this earth if it was a one-to-one function, all right? So this is an example of a one-to-one function, all right? Every x has only one y and every y has only one x, okay? So that's one-to-one. This guy's a function. It's okay that x1 and x2 is going to y1. It's okay that these two guys have the same birthday. That's totally fine. That is a function, but it's not one-to-one because y has an image to 2 x's. So it's a function, it's just not one-to-one. Okay? And then last but not least, well, this is the other scenario. Well, this is not a function because this dirty dog has 2 birthdays. You can't have 2 birthdays, Gavin. You crazy dog. All right, so hopefully you understand the difference between what a function is, what a one-to-one function is, and then we obviously know what not a function, okay? All right, so visually, what's going on here, there's a test for us to do to see if it's a function. We know the vertical line test. For every x, there's only one y, so we use the vertical line test. These are both functions. But now if I want to do a one-to-one function, we do the horizontal line test, okay? So when I do a horizontal line, horizontal has a z in it. Z is right next to the y in the alphabet. That's a y equals line. So let's say that's y equals 300. I don't know, I just made that up. you will see that it intersects in two spots. I would have negative 10 comma 3 hundo, and then I would have positive 10 comma 300. Okay. So yes, this is a function, but it's not 1, 2, 1. Okay, because negative 10 and 10 are both going to 300. Okay, so not one-to-one. Function, but not one-to-one function. Versus, yes, this is a function that passes the vertical line test, and if I look, these guys only intersect in one spot. So every x has exactly one y. So yes, this is a 1-to-1 function. Okay, so see the difference. Yes, these are both functions, but this is not 1-to-1. This one is. Okay. All right, do you guys have any questions on what a 1-to-1 function is? All right, we're going to switch gears, so push the clutch in. Dun, 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 dun. Put it into second gear. We're going to do inverses now. All right, when you're doing your homework, when you're doing questions on my math lab, you'll see like 5.2 number 27. When you're doing this, this is what you're looking at, okay? By definition, inverse functions, which is denoted with a little f, a little negative 1 on top. This reads the inverse of f, okay? All we have to do for inverses is take the x's and y's and switch them. So take the x's and y's and switch them. That's our definition of inverse. So x's and y's, domain and range values, switch them, okay? So I've got a function, okay? It says find the inverse and determine whether the inverse represents a function or not. Okay, so this is a function. Now I want to come up with the inverse. Okay, these are my x's, these are my y's. I'm going to flip-flop them. So my domain is now my range. So 5, 2, and 3. And 7, 8, 9 was my range. Now that's my domain. Those are my x values, 7, 8, 9. And then now we have images over, like we had before. 5 goes to 7, now 7 goes to 5. 2 goes to 8, now 8 goes to 2, and 9 goes to 3. Okay? So I have to look now. I have to decide. Determine if this is a function now. Function, not a function. What do you guys say? Yes or no? Give me a thumb. Function, not a function, or shout it out. Thumbs up, function. Thumbs down, not a function. I got big thumbs here. Big thumbs going up. This is a function. It is a function. Fantastic. So let's take a look at the next one. Okay, I got 12, 16, 80, 8, 9. Okay, I want to do the inverse. By definition, inverse tells me to take my domain and ranges and flip-flop them, take my x's and y's and flip-flop them. So 8, 9 was my range, that's now my domain. 12, 16, and 80, which is my birthday, by the way. 12, 16, and 80 is now my range. Image over, 12 and 16 went to 8, now 8 goes to 12 and 16. 80 went to 9, now 9 goes to 80. Function, not a function. What do you guys say?
Function.
Function or not a function? Does every X only have one Y? Does every person only have one birthday? What do you think?
Never mind, not a function.
All right, yeah, this guy, not a function. So not, because 8 is going to 12 and 16. That dirty dog has 2 birthdays. This guy has a birthday on the 12th and the 16th of January. You can't do that. All right, so not a function. Okay. Any questions with that? Now look at the big picture. All right, look at both of these together. Okay, I gave you 2 examples. These were both functions to start. When we did the inverses, we got one that worked and we got one that didn't work. Okay, so what can you conclude Make a hypothesis. What do you think on when you do an inverse? What is going to guarantee that the inverse is always a function? What do you guys think? What's going to guarantee the inverse is a function? Help me out. Use your microphone. Use your chat. This is a hypothesis. We're brainstorming. It's okay just to throw out suggestions. Sometimes they stick.
If it's 1,
What's that, Joe?
if it's 1x to 1y.
Yeah, so I think you're kind of breaking up. Yeah, if this guy's 1 to 1, if I have a 1 to 1 function, then the inverse is going to be 1 to 1. This guy is not 1 to 1. Okay, and if it's not 1 to 1, it's still a function, but if it's not 1 to 1, then the inverse is not going to be a function. So fantastic, Joe. Atta boy. All right, so 1 to 1, inverse is a function, not 1 to 1, not a function for the inverse. Okay, so this is one way they might do it. They might use boxes or circles or what have you, or they might give you something like example 3 or 4, where they just give you a list of coordinate points. Okay, again, same idea. Remember, x's is your domain, range is your y's. Okay, so if you need to, you could make your little balloons here, or Easter eggs, or whatever you want to call them. This is your domain, this is your range. And then I got my inverse. All right, so I take a look. 2 goes to 6. -3 goes to 7. 4 goes to 9. 9 comma 10 is 9 goes to 10, like that. Okay. Well, this is 1 to 1, right? So if I flip flop these, now I have 6, 7, 9, and 10 are my domain, and 2, -3, 4, and 9 is my range. I just took the bubbles and flipped them. And now 6 goes to 2, 7 goes to that. So this one's 1 to 1, like Joe said, and now this is a function, guaranteed. Okay. So that's one way to do it. You don't have to rewrite it like the bubbles, but it might help you. The other option is if you want to go through and just write them out. So I want to come up with the inverse, just take all your coordinate points and flip-flop them. So 2 comma 5 is now 5 comma 2. -1, 3 is now 3, -1. 3, 7 is now 7, 3, and 4, 5 is now 5, 4. Okay, I take a look. Every x can only have one y. And I see I have 2 5s, right? I have 5 going to 2, and I have 5 going to 4. So I know this is not a function. Okay, so you could do either way. All right, whatever helps you answer the question. Okay. How we doing on inverses, guys? Give me a thumb. Where are we at? Thumbs up? Any questions? People without their cameras, I hope you're understanding this. Speak now on chat or forever hold your peace. All right, gang, we're almost done. Got 3 more quick examples. All right. Goal number, let me look. Goal number 2, obtain the graph of the inverse from the graph of a function. When you guys are doing questions 45 through 50, they're going to ask you to graph the inverse. Okay, we want to draw the graph of the inverse, and I'm given this function. Okay, well, you got to know what an inverse is. What's the definition of an inverse? What have we just been doing? And let me know if you can't see these. I can zoom in a touch. What's the definition of inverse, guys? What are we doing?
You switch x and y.
There we go. That's all we got to do. We got to switch our x and y values. Okay. So I have 0, 3. So I'm going to switch that to 3, 0. Now, I don't have axes on here, so I'm going to go ahead and draw those in. You don't have to. It just helps. Hope you guys are writing this down. This could be a quiz question, test question, or I should say quest. Since we're doing a quest. Okay. So 3 zeros on the x-axis. 1, 2, 3. I make a good old dot. I've got negative 3, 0. Switch those guys is now 0, negative 3. Uno, dos, tres. There's your German lesson for today. I got negative 3, negative 4, negative 3. Switch those guys to negative 3, negative 4. So I count over 1, 2, 3, and down 1, 2, 3 to the 4. And then the last one, go ahead and flip those guys, negative 7, negative 4, flippy flops. Now I have negative 4, negative 7. Okay, so these are my new inverse points. This is the original function. So I graph that guy, I count over 1, 2, 3, 4, down 1, 2, 3, 4, 5, 6, and 7. Okay. Now I can connect the dots. And now take a look at my pretty picture I made. What do you guys notice about this thing? What does it look like is happening? Somebody new. Let's get Amshul. What do you notice? Jen, what do you notice? Jess. Who's the quickest to their microphone? Sydney, what do you guys see? Connor, what do you see? Look at this graph compared to the original one.
It's a reflection of the other one?
Yeah, it's like a mirror image, right? It's a reflected over, okay? Now, what's kind of cool, if I draw in the perfect diagonal line right here, if I draw in this nice pretty line, which is y equals x, okay, I get a reflection over that, okay? So these guys are a reflection over the line y equals x, okay? That should make sense. If you're taking your x's, y's, and flip-flopping them, right, they're going to reflect over the line where y and x are the same, okay? Pretty cool stuff. Awesome. Why are we doing this, Mr. Gotsch? Well, we're going to talk about exponential and logarithmic functions. All right? If you like money and you want to grow your money exponentially, you probably want to know how to do that. Versus, you know, understanding how a pandemic works and how things grow exponentially, probably want to know how that works too. All right. Let's finish up. Do you guys have any questions on number 5? Goal number 2, how to graph an inverse given the function. Just take your x's and y's and switchy switch. All right. We got 2 more left, guys. So I got the next one. Let me zoom in a little bit. Focus that. This is just like the last example from yesterday's notes. They're asking us to verify that these are inverses of each other. Okay, this is like questions 35 through 44. So if they ask you to do that, that's what we need to do. All we need to do to verify, we need to show that f of x and g of x, those composites, like what we did yesterday, which is why we did yesterday's stuff, is equal to x, which are equal to each other. Okay? So here's the idea. Okay? Here's my domain, right? I've got x. Here's my range. That's my y value, right? Well, in the original function, x maps to y. The inverse sends me back to x. So if these guys are inverses of each other, I should start at x and I should finish at x, is the idea. So when I do the inverse, or excuse me, when I do a composite f of g of x and g of f of x of inverses, it should equal x when I'm done. Okay, that's the idea. Hopefully that makes sense. So I'm going to verify, I'm going to prove that these are inverses. Okay, so we're not going to make, statements and reasons like we did with proving triangles congruent. All we're going to do is a little algebra here, gang. Okay, just like we did yesterday. This is great review from yesterday of composite functions. I've got f of x is 2x plus 6, and I've got g of x in red is 1/2 x minus 3. And I want to do f of g of x, like that. So I'm inputting this guy here. I'm going to take this, I'm going to input right there. I'm inputting 1/2 x minus 3. So the f function is 2x plus 6, but instead of x, I put parentheses. And in parentheses, I'm putting in this guy right here, 1/2 x minus 3. All right, we need to simplify. How do you simplify that, guys? Shout it out. What do you got to do? What do we have to do? What's that?
Distribute.
Yeah, we got to do a little distributive property. Here we go. Whee! If I take 2 times 1/2 x, those 2's cancel, leaves me with just 1x or x. So half of 2 is just 1x. 2 times -3 is -6. And then we have this plus 6 on the outside. Those guys cancel. Yes, I'm halfway done. Look at that. Now I do the other way. Now I do g of f of x. F of x is 2x plus 6. So the idea is I'm going to take this and I'm going to put that right there on this x. Okay, so I have 1/2 x minus 3. And this time I'm doing 2x plus 6 here. A lot of times they solve in exactly the same way. We take this 1/2, we distribute. Half of 2x is 1x, for x. Half of 6 is 3. So 1/2 times 6 is 3, and then this minus 3 on the outside. These guys cancel, equals x. So I show that f of g of x and g of f of x are equal to x. So then these are inverses. If you find that one of them doesn't work, one of two things is happening. Either they're not inverses of each other, or your algebra is wrong. So just verify. If you're getting those wrong, look at your algebra. Maybe you're not multiplying correctly or something. All right, this is how we check our work for the last one. So now the last question is, well, how did they come up with these two are inverses of each other? All right, how did they know this and this are inverses? How did they get those? That's the idea of the last one, okay? So our last goal for today is, how do I find the inverse? So when you're doing 51 through 62, this is how you do it, okay? By definition, what does inverse mean? What are we doing when we're doing inverses? Say it again. What do we got? What are we doing? When we're doing inverses, what are we doing here? What's the definition of inverse? How do we come up with a graph of an inverse? Can you hear me? Is this thing on? Am I frozen? How do you find an inverse? How do you find the graph? How did we come up with these? This guy right here. What do you think? Madeline, Zach, Caitlin, AJ, Paige, how do you guys come up with an inverse? How do you do it? Lisa, Duncan, Madeline, Gavin, how do you guys come up with an inverse? How do we graph this, guys? What's the definition? Big goal for today. Shout it out. Can you hear me? Yes. Somebody help me out. What's the inverse definition? What are we doing?
Flipping it, right? Gotch, reflecting almost.
Yeah. And how do we go from this to this?
We did the equation foiled, right? We said f of x t thing to the equal to. Oh wait, switch right.
We gotta switch those x's and y's, right? So good guess, Joel. Okay. Right here. The answer is right here. We gotta switch your x's and y values. So when I look, they say, hey, the function, this guy right here, this is a line, right? Line is 1-to-1 if it's a oblique line. It says find its inverse and check your answer. Now, I don't have to worry about checking it. You can check it if you want. I know my algebra is going to be good, so I'm not going to worry about that. Okay? But I need to switch the x and y values. Wait a second. I don't see no, I see an x. Where's the y? What's the y value? You guys see a y there? Shout it out if you see it.
It'd be 4.
No, good guess. Where's the y value? I got f of x equals 4x plus 4. This is a line. Usually lines look like y equals mx plus b. Where's the y?
Is it 0?
No, good guess. Normally it looks like this, right? Y equals mx plus b. This is definitely a line. This is your slope. That's your x. That's your b. The question is, what's y? You guys got a case of the Tuesdays, I think. This guy right here, isn't that f of x is the same thing as y, guys? Oh, yeah. You guys remember that function notation? Don't forget, f of x is the same thing as y. So if I'm going to switch my x's and y's, it's probably better to rewrite this thing. Okay, so this is my original, right? My original function. Well, now I want to come up with the inverse. I want to come up with the inverse of f of x. That's what I want now. Step 1. So step 1, switch x and y values. So these guys are going to flip-flop. Instead of y equals, I'm going to do x equals. And instead of 4x, I'm going to do 4y plus 4. All right, all I did was I took my x's and y's and flip-flopped them. Okay, that's step 1. Step 2, solve for y. Got to get this y by itself. I'm going to subtract the 4 over. X minus 4 equals 4y. Now I got to get that y all by itself. I'm going to divide it over. Divide. If you do it to one guy, you got to do it to the other. Just like if I'm bringing donuts in at the Corona time, I can't just bring in donuts for Leo, Lorelei, and Joe. I got to bring them in for everybody. That's just not fair. So final answer, I get y equals x over 4 is the same thing as 1/4 x, or x over 4 either way, and then negative 4 divided by 4 is negative 1. Okay, I'm okay with this. You could also put a little negative 1 on top to denote the negative. Okay, my math lab might ask you to make it inverse of f of x. was 1/4 x minus 1. Okay, this is, again, function notation. This is denoting, number one, it's a function, and it's the inverse of f of x. Okay, so I'm okay with either one of these, okay, but my math lab might be wanting that. And they might have the inverse of f of x equals, and then you just plug in 1/4 x minus 1. Okay, got to see what they want. Now, I could check my answer by doing this idea. I could take this and put it in here. Okay, 1/4 times 4x plus 4 is x plus 1 minus 1. The ones cancel, I get x. So I know it works out. So I would get something like this. Okay, so if they're asking you to find the inverse given a function, number one, switch your x's and y's. Number two, solve for y. And then there you go. You got your function. That's the inverse. All right, ladies and gentlemen.